In today's class, we are going to see the topic called sequences. So, what is a sequence? A sequence is a list of numbers in a certain order. So, sequence is called as a list of numbers in a certain order. Let us see an example. So, I will write an example 5, 15, 25, 35, comma, etc. This is called as a sequence. Why do we call this as a sequence? The first number is 5 and the next number is 15. The difference between these two numbers is 10. But we cannot conclude with the first two numbers itself. We have to check with the third number also. If you again see the second term and the third term, the difference between the two is again 10. And the third term and the fourth term, the difference again between them is 10. So, this is a sequence, whereas the difference between all the numbers is the same. So, we call this as a sequence. In a sequence, each number is a term. What does it mean is, this is called the first term in the sequence and this is called the second term in the sequence and this is called the third term in the sequence and this is called the fourth term in the sequence. So, in a sequence, every number will have its own position. First term, second term, third term, fourth term, etc. It goes on. And how do we represent the terms is, for example, first term in a sequence is denoted as A1, which means the first term is represented as A1. The second term in the sequence is represented as A2, which means A2 represents a second term in the sequence. Similarly, third term can be expressed as A3. Similarly, nth term in a sequence can be represented as an. Therefore, in general, a sequence can be written as A1, A2 up to an. What does it represent? A1 is the first term in the sequence, A2 is the second term in the sequence, similarly an is the nth term in the sequence. So, in this sequence 5 is the A1 and 15 is A2, which means second term in the sequence, 25 is A3, third term in the sequence and 35 is A4, fourth term in the sequence. So, this is a sequence given. Now, what we have to do is, we have to write the nth term for this sequence, because nth term is not represented. We can write the nth term and we should check whether the nth term is applicable for all the terms in this sequence. So, now what can we do is, if you look at this sequence, the first number is 1 and the second number, that is second term, is 3. The difference within this is 2, which means if I add the number 2 to 1, I will get 3. Similarly, if I add 2 to the term 3, I will get 5. If I add 2 to the 5, I will get 7. So, in this way it is a sequence. Now, what we are going to do is, we have to write the nth term, which is an. We will use an arithmetic progression method to write the an in a simple way and also in a right way. If we use the arithmetic progression method, we can write it in a certain way. So, I can use only the arithmetic progression in when the difference between this is common, which means the difference between the two terms is 2 and the difference between the next two terms is 2. Only when the common difference is equal, then only I can use the arithmetic progression. So, I am going to use the arithmetic progression. In arithmetic progression, an can be written in a plus n minus 1 into d. What does A represents is, A represents the first number in the sequence. Therefore, A equals to 1. And what does the D represent is common difference between any two terms in the sequence. So, D equals to 2. I will substitute the value of D and A in this nth term. Therefore, we will get the AN for this given sequence. So, A value is 1 plus n minus 1 into D value is 2 according to the sequence 1 plus 2n minus 2, which is equals to 2n minus 2 plus 1 will give me minus 1. Therefore, the nth term for the above sequence is 2n minus 1. Let us also check whether the sequence we have bring it is right or not. How to check that is, we put the values of n varies from 1 to 3, it goes on. If I take the value of n as 1, I should get the first term. If I take the value of n as 2, I should get the second term, and so on. Let us check. So, first if I take the value of n as 1, what will I put? In places of n, I have to substitute n is equals to 1. Therefore, A1 is equals to 2 into 1 minus 1. So, 2 minus 1, which is equals to 1. A1 we got as 1, as well as in the sequence the first term is 1. So, next we will check for number 2, A2. Therefore, what we have to do? We have to substitute the value of n as 2 in this general term. What will we get? A2 equals to 2 into 2 minus 1, 2 2s are 4 minus 1, which is equals to 3. Again, if you see, A2 we got as 3 and the second term in the sequence is also 3. So, in a way, if we proceed, similarly, if I take the value of n as 3 and substitute in this, I will get the third term, that is A3 as 5. So, therefore, the general term we considered was the right for the above sequence. This is how we write a general term for the any given sequences. This is the second illustration. We have to write the nth term for this sequence. So, nth term is represented as an. If you see in all the sequences, the numerator is 1. So, that is not going to change. Let us consider the numerator as 1 and we have to write the nth term for the denominator. As I told you in the previous problem itself, the denominator, the sequence is given as 2, 3, 4, 5. I am considering only the sequence in the denominator 2, 3, 4, 5. If you see, the common difference between any two terms is 1. So, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 will give me 5. So, this is the common difference. When the common difference is the same between any two terms, we can use the arithmetic progression. According to the arithmetic progression, we can use the formula for finding the nth term is a plus n minus 1 into d. Now, what is the value of a? Which is always the first term, which means a is equals to 2 and d represents the common difference between any two terms, which is 1. So, we will substitute the value of a and d in the above, we will find the an. So, a value is 2 plus n minus 1 into d value is 1. So, if I simplify, 2 plus n minus 1, n plus 2 minus 1 is plus 1. Therefore, 1 by n plus 1 and n varies from 1, 2, 3, etc. It goes on. So, this is the nth term for the above sequence. Let us check whether this is the nth term. This is the right nth term for the above sequence or not. If I consider the value of n as 1, I can substitute the value of n in the above sequence as a1 is equals to 1 plus 1, which will give me 1 by 2. Let us check for the second term also. Therefore, I will consider the value of n as 2. We have to substitute the value of n as 2 in this. A2 equals to 1 by 2 plus 1, which will give me 1 by 3. So, the sequence is the right for the given sequence. We have considered it so. And sequence is classified into two types. What are the two types is, one is the finite sequence and the other one is the infinite sequence. First one, let us see finite sequence. If the number of elements in a sequence number of elements in a sequence is finite, it is called as finite sequence. So, number of elements in a sequence, if it is finite, then we call it as a finite sequence. Let us give an example for this. Example is 1, 2, 3, 4. Is this a sequence? Yes, it is a sequence because the difference between any two terms is 1. As well, I have stopped at 4. So, there are only 4 elements in the sequence. Therefore, it is called as a finite sequence. And the second one is, if the number of elements in a sequence is infinite. If the number of elements in a sequence is infinite, it is called as infinite sequence. So, if the number of elements is infinite, it is called as an infinite sequence. Let us give an example for infinite sequence as well. So, 2, 4, 6, 8. Is this a sequence? Yes, it is a sequence because all the terms are the multiples of 2 and it forms a sequence as well. It does not end anywhere. It goes on. There are infinite number of elements in this sequence. Therefore, this sequence is called as an infinite sequence. Next is sequence as a function. Whether the sequence could be represented as a function? Yes, it is. A sequence is considered as a function. And when a sequence is considered as a function is when f is a mapping from set of natural numbers to the set of real numbers. Set of natural numbers to the set of real numbers. Then it is called the sequence as a function. So, let us write the sequence as a function in general. So, we are going to denote it with an arrow diagram. So, f is a mapping from a natural number to real number. Then only it is said to be as a sequence as a function. Natural number starts with 1. We all know 1, 2, 3, 4, 5, etc. It goes on. Real values I am considering it as in general A1, A2, which means first term, second term, third term, and it goes on like this. And in general, this can be represented as f of k equals to ak. Why we are representing like this is, and we will take the k value varies from 1, 2, 3, etc. It goes on. We all know that this function can be written as f of 1 is equals to a1 and the second term is f of 2 is equals to a2. So, in general I have written it as f of k equals to ak and varied the values of k from 1, 2, 3, etc. It goes on. So, we will see how it is. If I substitute the value of k as 1 in this, what will I get? F of 1 is equals to a1. If you see, we are getting the first term, which means f of 1 is equals to a1. So, the generalized term what we have written is the right one. Similarly, if I take 2, f of 2 is equals to a2, we will get the second term. So, if a sequence is, that is f is a mapping from a natural number to a real number, then it is said to be as a sequence as a function.